Hello and welcome back to another episode of Measurement in a Minute. I'm your host, 𝗦𝗧𝗔𝗬𝗪 with Lakeside Process Controls. And in today's video, we're continuing our discussion around Rosemount micromotion flow meter technologies. In particular, we're talking through entrained air and a feature Micromotion's Coriolis has, which is called advanced phase measurement. Now, advanced phase measurement is software that is part of our 5700 transmitter. It's a patented software that's designed to handle two-phase flow situations. Now, it can handle this with gas in liquid stream as well as liquid in a gas stream. I know we didn't talk about that in those previous videos, but it can help with both of those. And this is an algorithm that offers up to 3% accuracy in up to 15% gas void fraction. Now, it can offer improvement beyond that, but that's just what the guarantee is for. And let's talk about how this actually works. Now, we understand what happens when we have entrained air in our Coriolis flow meter and the measurement effects, but let's just review this once again. So we understand that our mass flow, that middle line there, is virtually unimpacted. The mass of the gas is so insignificant that the mass of the mixture is basically the same thing. So we understand that. Two, we also understand our volumetric flow rates are over-reporting. Why is that the case? Well, because our density has dropped off. Volumetric flow is just the mass flow divided by the density. And three, we understand that the drive gain spikes. Maybe so severe that it goes all the way to 100%, but it typically increases. Our Coriolis has to work harder because of that decoupling effect to keep at that natural resonant frequency. This happens in our Coriolis flow meter for all two-phase flow applications, and because we can measure all these things with a Coriolis flow meter, we can confidently determine that we do have a two-phase flow situation. That's going to be indicative because of that drive gain increasing, that density dropping. If we know those two things are consistent, we can find ways to remediate for this impact to our volumetric flow rates, which is especially important in product transfer applications. So how do we do this? Okay, and we have a very similar chart that we had to a few videos ago where you have those green dots, which are our density, and then we have now what's something called drive gain, which we talked about, which is spiking. And what we're doing here is we're looking for that drive gain to spike and that density to drop. The reality is when a bubble comes through, did your density really change? Or should I say, did the density of your liquid really change? The answer is probably not. Right? The reality is the mixture has obviously a changed density, but the liquid is probably the same density. So what the remediation does is it looks back at the last known good density value you had. When you did not have two-phase flow, it holds that density value constant, and it uses that density value when determining volumetric flow rates, as well as determining concentrations, which is also impacted in two-phase flow. Now, it seems very simple, but you would be very surprised at how effective this is and how much it can reduce your total error, especially when you look at totalizations during product transfer applications. And this assumption is likely valid depending on how long you have these two-phase flow situations for. And so if we look at what actually happens, in the next slide here, this would be an example using our ProLink software. And at the top, we can see our drive gain in those blue dots spiking, and then we have our density in those green dots dropping off. Now, the bottom graph is concentration. Think of it as really the opposite impact of volumetric flow rates. So typically the volumetric flow rates are over-reporting. In this case, our concentration is under-reporting. So just the opposite effect. And you can see that directly happens when we have those two-phase flow conditions. So the Coriolis flow meter with their APM software enabled, it has 1 point of dropping where it has that density slightly drop and the drive gain spiking. It realizes this is two-phase flow, holds those density values constant. Now you look at that bottom graph for concentration, would be the same thing for volumetric flow rate. It can hold a more realistic level for your volumetric flow rates or for your concentrations, and ultimately remediate for these conditions. And this is a significant impact, like I said, especially if we're looking at totalizations during product transfer applications, and it's a very, very handy tool that we have patented and built into our 5700 transmitter. Should you have any questions about Micromotion's Coriolis flow meters or any other of our products, please reach out to us at www.lakesidecontrols.com. Thanks and have a great day.